For example 4, it says that we have a continuous function f, and the right Riemann sum approximation for the integral from 0 to 2 of f of x dx with n subintervals is this expression, 2 times n plus 1 times 3n plus 2 over n squared for all n. So what is the value of the integral from 0 to 2 of f of x dx? Okay, so if we have our sigma notation here of f of x times our delta x as we let the limit of delta x go to 0, okay, this is essentially giving me the integral notation. Okay, we also know that this is this expression 2n plus 1 of 3n plus 2 over n squared is going to give me the Riemann sum approximation, but we also know that as we apply the limit to this, if we have the limit as n goes to infinity, it gives us an infinite number of subintervals. That's going to be the same as our integral as well. So both of these expressions are going to give us the same integral. So this is going to be the integral from 0 to 2 of f of x dx. If I let delta x go to 0, these expressions here represent discrete expressions. But if I allow the intervals or the delta x go to 0 or the subintervals go to infinity, I'm getting the exact area. So these two things represent the same thing. So if I want to solve for, in this case here, the question is asking me to solve for that, I just need to apply the limit to this expression. So as I apply the limit to this expression, I'm going to end up with 6n squared plus dot, 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 dot. All the other terms are going to be lower powers of n. And then over n squared, well, those are going to cancel out. So I'm going to end up with an area of 6 using an infinite number of subintervals. That means the exact value of the area under that curve is also 6 units squared. So it's important to recognize that this expression here that I've given, I'm just going to highlight it, this expression is for Sn.